All right, guys. We're going to talk more today about motors. We talked a little bit on Thursday about kind of the bottom end of a motor and what those things are. You got your crankshaft and what your crankshaft journals are, and those are the machine parts. And we talked a little about bearings and how anything mechanical, things like friction and vibration are the enemies of things mechanical. So a lot of this stuff, since we have a lot of things going on with an engine, we're really just working on reducing those things and kind of managing that vibration and that friction to make sure we have clean running parts. All right. So I'm still trying to do my best to keep this as generic as possible. There's dozens and hundreds probably of different engine designs, so it's difficult to talk about just one engine design. So I just want to understand the concept of how things work. All right, that's kind of my goal. So today we're going a little more about the camshaft. All right, and some components around that and how that helps and affects the basic operation of the vehicle. All right. So here's your camshaft. You can kind of see it here. You got your cam journals. Again, these are precision machined. You'll have bearings around those to make sure that you can rotate. It stays in the correct place. But anytime you see a journal, those are machine parts. All right, that's a machine surface of a part, and typically you're gonna have a bearing around that um, to help reduce friction. Um, you also have a camshaft position sensor. I'll talk about this in a little bit later. But that just lets you know the computer in your vehicle needs to know where your camshaft is. All right. And that's going to help it with the fuel system and making sure that the timing is all correct. And then you have this cam lobe. All right. And that design is what really does most of that's in my opinion probably the most important part of the camshaft, that cam lobe design. All right. And so this is a basic, I mean, this is a basic cam lobe design. And so you got to think about this. As this is rotating, all right, this is keeping in pressure. This is keeping in contact with your valve springs, all right? And then once this rotates, if it's going around this way, once this part right here starts hitting that valve spring, it's going to push that valve down, all right? It's going to open that valve. And this geometry is very important to how that works. All right. Everything has to work within time. And so this is going to let you know at what point it's going to start pushing that valve down. And that has to be in time with the crankshaft and the piston on where that's what step of the four stroke process that's in. It's going to, based upon this geometry, it's going to let you know how long it's open as well. All right. If I had something that was taller, coming up like this, that's going to do two things. That valve's going to open more, all right, and it's going to open for a longer period of time. And so this has to kind of match, this geometry has to kind of match the other parts of your motor to make sure that that valve is open at the correct time, it's staying open for the correct amount of time, and it's opening far enough to allow the air to come in or the exhaust to go out. All right, so this is a pretty important thing. You could change your camshaft. And you could put, like, if you want more horsepower or something like that, you can get a bigger camshaft in there and it's going to open that valve more and probably a little bit longer. You do have to worry about it because as that valve opens up, you got your piston moving up and you don't want those to come in contact with each other. All right. So there is a minimum or a maximum tolerance that you can have on that. But by changing your camshaft is a really easy way to increase horsepower in your car. I don't know how much it increases, but it will increase. Or on the opposite side of things, if you want a smaller camshaft to get more fuel economy, all right, you can do that as well. Although I don't see many of you guys wanting to do that. Um, okay, so on our thing here, let's see, what's our next part? So our camshaft, our camshaft versus our crankshaft. All right. So our crankshaft is the thing that does most of the work. It's the big, moves all the pistons up and down, right? And our camshaft does less of the work. It opens up our valves. Your crankshaft is a smaller gear, all right? So here's just a little gear generator, but I want to emphasize here that the ratio between these two is 2-to-1, all right? This crankshaft is going to rotate twice before this camshaft rotates once, all right? And that has to work with timing. You can see these dots right here. When you install two gears together, all right, in a vehicle, you actually have to install them at the right tooth to tooth contact to make sure that everything's opening and closing at the right time. And so you'll have these timing marks like this that kind of help with that. But the main emphasis is you have a 2-to-1 ratio between camshaft to crankshaft, and that affects the timing. We talk about our 4 strokes of our engine. All right. Remember, every time this goes around once, that's a stroke. All right. And so if it goes around 4 times, that's my 4 strokes of my motor. That is not accurate. If it goes around twice, it's the 4 strokes of our motor. I apologize. Anyway. As this goes around, I'm doing my intake stroke. This is opening a valve. It's closing a valve. Now it's not doing anything. We're having a compression stroke. We're having our power stroke. Now it's opening another valve for our exhaust stroke. So these two timed together is very important. All right. But for all intents and purposes, you have to understand that it's always a 2-to-1 ratio for every vehicle. The ratio between these two will be 2-to-1. And I did misspoke. I apologize. This is going to rotate. This doesn't rotate, whatever I said, 4 times for 4 strokes. It's 2 times for 4 strokes, being all the way up as 1 stroke, all the way down as a second stroke. That would be 1 complete rotation. All right. So just know that ratio, 2-to-1, every vehicle. That's the main part of that. All right, exhaust. So again, we're staying kind of on the top half of the engine for the most part. Our exhaust manifolds, they are, and our intake manifolds, very similar things, right? Exhaust manifolds, intake manifolds. Intake manifolds allow air to come into the engine. Exhaust manifolds allow exhaust to get out of the engine, goes through our catalytic converter past our tailpipe into the air. One thing about an exhaust manifold, I actually learned this the hard way one year. So these are the runners of your exhaust manifold, or the runners of your intake manifold, right? You need these runners, the distance between the flange here and your kind of main exhaust path. This runner, so this distance right here and right here, believe it or not, they're all about the same length. They need to be pretty close to the same length. We talk about our intake stroke, right? Intake stroke of our motor, our piston comes down, our valve opens up, and it creates a vacuum within the combustion chamber. All right, and it draws air and fuel into that combustion chamber because it creates a low pressure area, and everything else wants to come into that area. Well, something similar happens with our exhaust manifolds as well. So on our exhaust stroke, all right, our exhaust valve opens and our piston comes up and it pushes those exhaust gases out. And it pushes out down this tube right here. So I have exhaust gases traveling this way and moving out towards the back of my car. Now, that also creates a little bit of a vacuum in here, and it actually will pull the next exhaust, and it aids in this process so you don't have stagnant exhaust gas sitting in here. Now, so as this exhaust gas comes down here, all right, it actually creates a low pressure zone in this area. And then as this comes through, it's going to be able to help pull that exhaust through there as well. And that just aids in this whole process. So you want these to be about the same size. Now, I'll tell you, I learned this the hard way. This is years ago. A friend of mine were putting in new intake manifolds on a car. He and his dad had just kind of put together. It was an old Thunderbird. And anyway, they just kind of started rebuilding it, and they were working on it. And so we had the bright idea of, we want more air coming in this motor, right? We're going to go ahead, and we got little die grinders, and we kind of ground out the inside of these things, not touching the flange or anything like that. We knew better than that. But cut in here, and we just made this bigger. All right, we're like, it's going to bring in more air. You have more volume, make it bigger. But we did it all by hand. And what ended up happening is like some of these ports were bigger than the other ones. And so this cylinder right here was getting more air than the other cylinders. And so it was a really rough running car when we put it together and fired it up. Luckily, his dad was a parts guy at one of the dealerships and kind of just called us an idiot, and we got it fixed. But so it does matter. The geometry of these things does matter. All right, the distance there does matter. All the volume coming in here all wants to be relatively the same to have a smooth working engine. So my recommendation, I wouldn't mess with this too much. It's more complicated than I ever thought. So again, I learned that the hard way, but hopefully you guys won't have to do that. We're going to timing. Again, we're staying on the camshaft today for the most part. All right. I want to emphasize that the camshaft is twice as big as the crankshaft. Here you have a sprocket. All right. If a sprocket means that this is chain driven. So your relationship between your crankshaft and your camshaft and how those work together, you really have three ways of tying those together. All right. You have a timing belt, like you can see over here. All right. And that's going to wrap around there. If you have a timing belt, you typically have a pulley. You can have it geared. If your camshaft was down here, all right, and it was more internal in the motor, you could have a gear connecting this one to your two camshaft gears. You don't see that as much. I think it's a louder setup. It's not as quiet, so you don't see that as much. And plus, a belt or a chain, you can turn these other things on as well, which I think gives it a distinct advantage. And then so the other one would be a chain driven one. So you can have a belt driven one, you can have a gear driven one, you can have a chain driven one. Chain and belt are way more common than gears. But as you can see here, as this is rotating, I don't know what direction it's going to rotate, but it's going to rotate your camshaft. And it's also going to rotate your water pump, which is going to bring your coolant throughout your motor to keep it at an acceptable temperature. You could have these things route to your alternator, your power steering pump, anything else as well. This is a pretty basic setup, and then you may have like another belt-driven setup off to the side that kind of runs the other things. These things called idler pulleys, they're often there for tension. They're not going to be doing anything. It's an idle part, all right? It's just going to rotate. Sometimes you may want to position them in certain places. So, if it's rotating this way and this belt is coming down here, all right, if I just made that run right there, I probably didn't have enough tension on that belt. By moving the belt in here and coming at a little more aggressive angle, that allowed it to bite on this sprocket a little better, all right, so I can get good contact with that sprocket. Where if I came right through here, I'm not hitting that sprocket till down here. I'm not having a good contact there. May not be as good. So idler pulleys help with positioning of the belt and help with tension. This one right here has a tensioner as well, where it's just, again, that's just going to be a pulley, free spinning pulley, and you're just putting a little pressure on that belt to make sure that it stays in good contact and none of these things start slipping. Let's see, as I keep going here, we'll go into the fuel injection part of it. All right, so you'll kind of see how that works. So most modern vehicles now, we're all fuel injected. Carburetors are kind of a thing of the past. And so typically you have these on a fuel rail like you see here, and you have your injectors on a little port that's going to connect to your intake valves and actually spray gas inside of there. Here's another. So I'll talk about the fuel system on a later date, but as fuel comes into here, your injector right here is spraying on your inlet valve when your exhaust intake valve is open. Now, this works directly with your camshaft position sensor and your crankshaft position sensor. So your computer is reading the location of those two things. And then it's coming in and saying, okay, my camshaft is here, spray in cylinder 4. My camshaft is here, spray in cylinder 1. Spray in cylinder 2. Spray in cylinder 3. Now go back to spray in cylinder 4. And it's constantly doing this. And this is like thousands of times. I mean, this is in milliseconds here, so it's constantly doing that. But based on that position, it's just knowing where to spray fuel, and that's how it reads that. So this is typically it's a computer controlled part that actually is going to open and close the valve on your fuel injectors. Fuel injectors do get gummed up and do get dirty. It is a wear item. You will have to clean those or replace those from time to time, but they're not too bad to cover. And all right, engine flywheel. So this is typically, it's the big gear on the motor that helps start your motor. All right. Now, I will say this. I always call it a flywheel. I think technically if you have a flywheel is on a manual transmission vehicle and a flex plate is on an automatic transmission vehicle, that is important. We should use the correct terminology. I do make the mistake of calling them all a flywheel. I mean, when I started working on cars and learning about cars, most of the stuff that was around my house was a manual transmission. And so that's maybe where I got it from, but whatever. Flywheel or flex plate. And so is what happens. You typically have a starter. All right, you have a starter motor like this, small little gear here, a very, very high torque motor. All right, that's hooked up to your flywheel or flex plate along those gears right there, and that starts your motor. All right, we've turned over a car. You hear that, and then the car kind of starts up. That's again that flywheel is getting going. It's drawing in air and fuel. It's allowing exhaust. It's kind of getting the whole gas motor to take over until just the normal process of the motor can just run smoothly without that. All right. So that's one of the primary reasons for having a flywheel. Also, when you think about it, your engine is doing a lot of work, right? And you have forces of your engine everywhere throughout the engine, right? They're constantly, those pistons are constantly going up and down. But when those pistons are going up and down, only one of the four strokes actually creates power. All right, we have our intake, we have our combustion, then we have our power stroke. All right, then we finish off with our exhaust stroke. The power stroke's the one that's doing all the work. All right, and so as that power stroke comes down, boom, all right, that's putting a ton of torque on your motor. All right, and the flywheel, because it's such a big wheel, it has a lot of weight to it, it's constantly spinning. All right, it actually can absorb some of that stuff. All right, and it's centrifugal force. I don't know if you guys have ever been on like the Gravitron and stuff like that. At like the state fair, or merry-go-round or anything of those things, right? You want that energy to go to the outside of that flywheel. Well, that can actually dampen some of the vibration within our motor and help kind of have a more smooth engine ride. And then the last thing it does is typically the flywheel or flex plate is what connects your engine to your transmission, whether it be a manual transmission or an automatic transmission. All right. So flywheels are really important. They help start the car. They help kind of smooth out the operation. They can absorb some of that vibration. And then they also connect to your transmission and drivetrain. The last thing I want to talk about today is engine size. Is engine size. All right. So how do they determine when they say Mustang 5.0 engine? Like, what does that mean? This side, in this case, it's a 1.6 liter engine. What does that mean? All right. And so your engine size is actually the size of your cylinder. All right. Your cylinder inside the bottom half of your engine. And how they measure that, there's a couple different ways. I mean, I've only done it with like the fluid, but I bet it's probably easier to do other ways. But anyway, they measure the volume of your engine, of your cylinder, from top dead center to bottom dead center. All right. And so this is the volume that I bring in on my intake stroke. All right. And so they find the diameter of this, all right, multiplied by the length of the stroke. So the further this can go up and down, the longer your cylinder bore is, the larger your engine's going to be. And the larger diameter that is the larger your engine is going to be. So you take this volume measurement right here, and you multiply it by the number of cylinders that you have in your car, and that's your cylinder size. So if this is a V6 engine, each cylinder is going to have 1.6 divided by 6. All right. 0.2667. So they're going to have, each cylinder is going to have 260 cubic centimeters of volume in there. And that 6 cylinders, that gives you a 1.6 liter engine. All right. So that is how to determine the engine size. All right, guys, that's pretty much the things I want to cover. Camshaft, the lobe design, our gears, in terms of our relationship between our camshaft and our crankshaft is always going to be 2 to 1. Exhaust manifolds and intake manifolds and how those work. They bring in air or let air out specifically for each cylinder. Our crankshaft timing and how those work. Remember, we can have 3 ways of hooking up a crankshaft to a camshaft, typically a belt, chain, or a gear, with belt and chain being the more common. We use our camshaft for our fuel injection system. All right, because we have camshaft position sensors, so we know where our camshaft is, and that tells our sensor where to squirt gas into each cylinder. Our flywheel has a couple of very important things. It helps kind of start the vehicle for one, smooth out the engine operation as well, and then it connects our motor to our transmission. Our starter motor here is what kind of gets that thing to start. our cylinder heads. I'm sorry, how to measure an engine is the displacement between top dead center and bottom dead center multiplied by the number of cylinders that you have. And just kind of like the basics of stuff, like I guess I'll show this. This is just all the top half of our motor. All right, these are your cylinder heads. Here's your valve train, which is your valve springs, your valve keepers, your guides, and all that kind of stuff. So this would be the top end of the motor versus the bottom end of the motor, like we talked about on Thursday, which is your crankshaft and your engine block and those components, your pistons and stuff like that. So those would be the bottom half of your motor, or bottom end of your motor versus the top end of your motor. All right, guys. Hopefully that's starting to make sense, come together for you. This will really start coming together. Hopefully once we're back in class, you can physically touch these things and manipulate them and see how they work. I think that's a big part of this. So anyway, hopefully that worked for you guys. Enjoy the rest of your day.